Hi everyone, welcome to the final walkthrough video for CS111. This is Project 8 about journaling file systems. This is the final video, so I hope you've all enjoyed watching these videos. I hope these videos were helpful. Yeah, if you have any feedback about these videos, feel free to comment on Ed or feel free to comment in the course reviews. Yeah, because these videos will hopefully be helpful for future students. And if you have any suggestions on them, let me know. There's a good chance I'll remake some of these videos so that future students can also benefit from them. Yeah. Also, last video, give me a like, give me a subscribe. I'm not trying to build a YouTube channel, but it's kind of cool that I post these different videos for different classes like CS10, like 161, 111, 106L. And then I sort of have a little YouTube following going on. So yeah, give me a like, give me a subscribe. Otherwise, let's just jump straight into the video. Yeah, I'm in Chicago right now. It's Sunday, 1:30 Stanford time, so around 3:30 Chicago time. Yeah, but I know I promised to deliver a video by Saturday night, and I'm a little late, but I'm gonna get the video out so that you can watch it and hopefully get it done soon, week 10, because finals are starting, and hopefully you can finish this project as soon as possible. Now, this project, I personally think that the instructors are trolling y'all. Like, this spec looks horrifying. It is the longest spec I've ever seen. I've seen longer specs for other classes, but for CS111, this is a very long spec. Okay, and a lot of it is very dense. But the actual code you're gonna write is very short. It's like 10 to 15 lines of code. And it's not like those, it's not like the project 2 where it's like very few lines of code, but they're all like very dense and very hard to get right. Now, this code is like pretty straightforward. It's not like hard. There's no weird C++ issues with the code. The only difficult part is it's very hard to know, like there's so many different files in the starter code, you don't know what functions or what variables you're supposed to use. They're just all over the place. So basically the goal of the video is to show you where different variables are and point out what variables or functions you probably want to use. All right, that is mostly the goal for the project video. Hope that will be helpful. All right, so let's do a quick review of journaling. Okay, so let's go to here. Okay, and the way I'm going to review journaling is, actually, let me first teach you how do you get this dump. So I'm going to run this line of code called dump log, and this gives me basically a journal. Okay, so let me explain how to get this. This code walks you through like step by step about how you can set up the file system. I'm going to post this. This is sort of a simplified version of that. I'll post this just so everyone can just copy paste this in. Yeah, you can just run this and then everything is set up. But once you get that set up, you can also just you might as well just do run tests as well, and that will run the code for here. Now, once you get this, you get a journal. So let's talk about what a journal is. A journal is essentially it's writing down every operation that is going to be performed on the file system. And the goal is that in the event of a crash, so if your system crashes and like a bunch of like stuff you were doing in the system was lost, that when the system boots up again, you can go through your journal entries and you can sort of replay everything, right? Everything that was not confirmed to have been written to the file system, you can replay it again so that you can ensure that the file system is correctly, it has successfully recovered. It is in a consistent file system state. And depending on which transactions were committed, all the information that you said you committed were written to the files. All right, let's talk about the concept of transactions. Remember, a transaction it's essentially an atomic operation. It's saying everything within a transaction, either all of it happens or none of it happens. It's atomic. Okay, and that's sort of the idea here. A transaction is signified by, it starts with a log begin entry. So that is the beginning of a transaction. And then it ends at a log commit entry. Let me see if I can find one. Yeah, log commit here. Okay, so log begin, log commit, and everything else within it is part of that single transaction. In this project, you will only deal with a single thread, so these transactions won't overlap. There's only one thread that's writing to the journal, so you're always pretty much guaranteed that the log begin, you see a log begin, then you see a log commit, then you see another log begin, and then you see another log commit. Okay, yeah, they won't overlap. They're just transactions, one after another. And then what the goal of each transaction is that when the journal is, when you're writing to the journal and you're writing each operation down, once you get to the commit, once you write down the commit, okay, once that is written to the file, then even if the file crashes anytime after that, okay, whether or not the actual changes persisted to the file system, no matter if that happens, doesn't matter. When you replay the code, as long as there's a log commit, as long as that transaction has a commit at the end, you will ensure that that transaction is reflected, whether or not you need to replay it or not. Okay. Yeah. Yeah. Meanwhile, if you don't see the commit, then that means this transaction should not happen and will be ignored. Okay. The different types of operations in the transactions. Each of these are idempotent operations, and they basically represent any change you can make to a file system. One change is you can write to a sector, right? You can update the contents within a sector. So that's a LogPatch, LogPatch entry. There's also the log block alloc entry, which marks a block as being used. Remember, there's a bitmap in the file system that marks which files are used. So not which files, which sectors are used. So this marks a particular sector as being used. And then there's also a log block free, which is just the reverse. It marks it as unused, as free. Okay, so that's basically a quick review of journaling. In this, there's one more thing about journaling I want to mention, and that's checkpointing. Even when you see a commit, that does not mean that the changes have persisted in the file system, right? Remember that you are always writing to a cache buffer, right? A block cache. You're always writing to that cache, and then every so often, you remember the concept of delayed writing. The contents of that cache is then written to the file system. It usually takes some delay, like 30 seconds. Okay, so you're not guaranteed that even if you see a commit, that change has persisted to the file system already. Okay, so later on, even if you see a log with a commit, you have to replay that entry. The exception is this thing called a checkpoint. When you are certain that a transaction has been fully persisted to the file system, right? Everything in that, all the writes in there are not just in the cache, but actually have persisted to the file system, then you can sort of mark a checkpoint saying that everything before this point has successfully completed. Okay, so when you actually do the replay, you don't have to start at the very beginning of the log. You can just start at the checkpoint. Okay, and you can actually test that. If you do here, you remember this dump log had two different transactions, but if I only print out the transactions starting from the checkpoint, so I just add a C here, and you can see that there's only, never mind, there's so two. Okay, well, one of the other examples has, let me find one. One of the other examples, unlink. Okay, well, yeah, this one has actually the checkpoint. So if you remove the C, you will get a. Oh, actually, I know the issue. Yeah, because I need the dash C. Okay, maybe not. Anyways, one of these has a checkpoint, and then if you see the checkpoint, then instead of showing you the whole log, it will only show you the entries after the checkpoint. Those are the entries you have to replay. Okay, now we're enough of the review. The nice part about this project is You don't have to implement any of that. You don't have to implement the checkpointing. You don't have to implement the commit and the stuff. You don't really have to implement any of that. You need to understand it though. Okay, just a fair warning. This is a pretty good exam coding problem. So make sure you understand it. Make sure you can answer questions about it. But for this project, you don't have to implement any of that. That will take more than 5 to 10 lines of code. Instead, what you have to implement is you have to implement, given that the starter code already handles the writing of the log. So I forgot which file it is in, but one of the files actually writes the entries. It actually writes the log. So every time you modify the file system, it writes a log entry. You don't have to do that. Then after the crash and the system tries to recover, it goes through the log and it parses all the entries. Okay, you don't have to write that code. In fact, you can actually find that here. Yeah, check TX basically parses each transaction and it makes sure that there is a log commit at a log begin at the beginning and there's a log commit at the end. If there's no log commit at the end, it's just thrown out. Okay, so that parsing is done by check transaction. Thank goodness you don't have to code this. You also don't have to do any of the checkpointing. Okay, the checkpointing is all handled for you. I believe the checkpointing is like somewhere here. Yeah, there's some checkpointing here that's handled for you already, and you don't have to worry about there's also this concept of a rewind where when you reach the end of the log, you want to reuse space. So you go to the beginning of the log and you write over that. Assuming there's a checkpoint already like later afterwards, you can safely reuse that space. Okay, so you don't have to implement any of that. That's already done for you. What you do have to implement is once you've parsed these transactions and once the starter code parses each individual operation, like a log begin or a log patch or a log LogAlloc, similar to the ones you see here. Once it's parsed each of these log operations, then the goal is, okay, given that operation, what changes to the file system do you have to do? Okay, what writes to the block cache do you have to perform? What modifications to the bitmap, the bitmap that represents the free sectors, what changes do you have to do there? Okay, that's pretty much all you have to do. Just make sure the changes to the block cache and to the bitmaps are successfully written. And where to get that information? Well, each of these entries, the E here, it contains these fields like the block number, the block offset, the bytes. You use this information to determine what information you have to write to the block cache, to different sectors, or to the bitmap. Okay. These 5 functions are overloaded, so they all have the same name, but they have different type parameters. These 5, starting from log begin, log patch, log LogAllocFree, log free, and commit. Log rewind, you don't have to implement anything here. Okay, and to implement these, I think we should probably walk through these. So yeah, let's walk through these, and then you can determine what are the actual lines of code you have to write. Okay, after we're done with that, then we can go to the different parts of the starter code and I'll point out what variables are important. So first, there's this log begin. Log begin, just remember, it represents the beginning of the log. It marks the beginning of a transaction. Think about what you have to do for that. Like when you're replaying, when you're actually changing stuff on the file system, is there anything you have to do when you see the log begin? Log begins are useful for parsing the different transactions, but is there anything you actually have to write there? I'll let you think about that. Log patch is important. Log patch is it's saying if you ever modify a sector, you have to replay that. You have to also modify it. You have to basically do that again. And inside this log patch struct, you get the block number. So which sector do you want to write to? The offset. So within that sector, what are you writing into that sector? And then the bytes. So what is the actual contents you're going to write into? So here we're going to write into block 2, offset 5 with these bytes. And this just so happens to be the inode. Okay, now you're not actually writing to the file system directly. Instead, you're going to write to the buffer cache, right? The block cache. And then I'll show you some functions later. You need to then have a delayed write. Okay, so that's log patch, definitely important. Log block alloc is here. That basically is saying mark this block as in use. So mark block 4, mark sector 4 as in use. You'll have access to the free map, where I'll show you where that is as well, and you can just modify the free map freely. There's also this 0 on replay parameter. There's a couple of reasons why this might be a 1. It's about metadata and how you want to zero out the metadata on replay. But honestly, okay, definitely understand it. Like for the final, you need to understand why that's necessary. Read all about it in the spec. But in the code, basically, if this is a 1, then you just zero out. Like you just zero out that block. If it's a 0, then you don't zero out the block. It's pretty much just as simple as that. Once again, you're still, if you modify the cache, you're really modifying the block cache. Cool. And then lastly, the block free, you're just marking the free map, marking a particular sector, like sector 4, marking that as free. Lastly, the log commit. Whenever you see a commit entry, see the commit entry, you know that you're at the end of the transaction. Is there any other changes you have to do to the file system, right? They're important to mark the ends of the transactions, but think about, like, is there actually anything you have to do for those? And I've sort of hinted, out of the 5 of these, some of them are blank. So don't be surprised if some of them are blank. All right, so that's the 5 functions. Now let's actually go into the starter code and let's figure out where the different parts are, because there's a lot of code here, and I'll admit I personally went through a bunch of them to try to figure out where different things are. So I'll basically share with you my findings. I highly recommend you just dig yourself, just try digging into this starter code yourself. I'm personally like a C++ enthusiast. I taught Windows Excel in the past, and yeah, I'm sort of in awe at how clean and how also just modern and interesting the C++ code is in here. There's a lot of very interesting C++ that is used here. Just to give you an example, there's a lot of, I don't want to waste your time, but there's a lot of very interesting examples in here. Like, oh, here. Yeah, there's a lot of very interesting examples. There are these very interesting templates. There's some very interesting, yeah, the use of string view, which is a C++17 thing. Yeah, there's just a lot of very interesting things going on. Anyways, if you have time, look into the starter code. Feel free to ask on Ed if you have any questions about this. Yeah, this is really a good exercise for you to get better at. One of the big goals of CS 111 is to become familiar with getting a large code base and going through it yourself and becoming very comfortable with, understanding code that other people have written for you and extending it yourself. So, this is probably the most similar, like a project that is very similar to what you would do as a software engineer. Okay, all right. Now that I have that tangent out of the way, let's actually go to the starter code. So first thing I want to mention is so let's just start at the beginning, replay, right? This is the file you're going to write to. And immediately when you see replay, you want to think, okay, what variables do I have access to, right? Sure, I have access to E, so these, I have access to these. Where can I find these, right? What is in them? So those you would go to log entry. Okay, yeah. Also, when you go to these, don't look at the .cc files, just look at the .ha files. So log entries, there's a header here. You can ignore that. You're not going to deal with the header at all, thank goodness. But the log entries themselves are here. So log begin, you can see there's no information in log begin. Honestly, you can't do much with log begin. There's no information in it. LogPatch gives you a bunch of information. It gives you the block number, the offset, and the vectors. It's basically the exact same thing that you saw down here, right? LogPatch, it gives you these 3 entries. Okay, so you have access to them. You can just do e.blockNo or e.bytes to get these values. Same for here, LogAlloc, you get these 2. Block free, you get this 1, and log commit, you get the sequence number. I'll give you a hint. You don't need to use the sequence number at all. Cool. All right, so that's the log entries. Let's go back to the replay. Is there anything else interesting about this class? What other variables do I have access to? Well, we had all access to the local variable, that's the parameter. There's also a bunch of instance variables you can use. So that's the ones up here. right? Because we're writing as the apply function as part of the v6 replay class. So we can use these variables. The only two that are interesting, or all of them are interesting, the only two that are useful for your project is this first one, the FS. This is a reference to a v6 FS. Let's dig into that in a bit. And there's also this bitmap. Let's look at the v6 FS first. All right, so you have this FS. What is in this FS? Well, we can go to the v6 FS and see what's in there. So v6 FS, you go in here and then you see a bunch of stuff. Let's look at the buffer last. Let's look at v6 FS first. Here, okay. So v6 FS has a bunch of stuff. Yeah, it has a bunch of stuff. And then there are these bread, bget functions. Okay, so the only important ones are, so you see there's a log here. That's definitely important. But you're not actually going to read from the log at all. You're not going to read or write from the log. Everything is done for you. So you don't have to touch this log. Yay. There's this cache. You have to write to the cache. So you'll definitely interact with the cache somehow. But the cache is kind of annoying to deal with. So the v6 FS also provides you with these functions which write to the or read from the cache for you. Okay, so you don't have to deal with those. You can just literally call bread and bget. Okay, how are these different? Bread reads a block from the disk, so it actually reads the file, while bget it does not read the file. It just gives you a buffer that you can populate, so that later it gets written back. Okay, so that's these two functions. Basically, if you need to read from the sector, use bread. If you need to write to a sector, use bget. Also, on the ed, someone posted a really funny joke about bread and bget. I'll link it to it on the walk in the ed post. All right, now that we're done with that, let's look at the ref. Ref here is basically just a pointer. Okay, just think of it like a pointer. Don't be scared of it. It's just a pointer. So it's a pointer to a buffer. Let's look at what a buffer is. A buffer is up here. And it just represents the buffer. And there are basically two important parts of the buffer. First is if you want to write to the buffer, okay, like if you want to modify the contents of the buffer, you modify this mem array. It's an array. So you can do you can do mem underscore 5 is equal to a character. You can modify a single character. You can do mem set. You can do mem set with. You can write over mem. You can just do whatever you want with mem. You can do all the string operations and array operations as well. Okay, so mem is just an array. You can do all the memory operations on it. How do you access mem? Well, remember that bget here. So once bget, you pass in a sector number. Let's say you want block 2. You get a reference to you get a pointer to a buffer. So something like bget, I want sector 2. This gives me a pointer to the buffer. So buffer. This gives you a pointer to the buffer. And then how do you actually use the buffer? Well, it's a pointer, so you can use the arrow syntax, and then you can either modify the buffer itself using mem, like this, and you can do all sorts of memory operations on this array, or you can, you have to do both. This actually modifies the buffer, like the buffer in the block cache. So this actually modifies the block cache. While if you want it to be written to the file system, then you use bdwrite. So you would then write. So this actually causes this to persist into the file system. You have to do both. You have to modify it first in the mem array, then you have to write it to the file system. All right, cool. So that's the buffer class. Those are the only two you have to worry about, mem and bdwrite. There's a lot of really cool C++ stuff going on here, but you don't need it. Okay. Yeah, nothing else in here. These are the inode structs and the dirent or dir entry structs you saw in project 7. Don't really worry about that. V6, yeah, we talked about bread, bget, and that's pretty much all you need to know for the V6 FS. All right, so let's go back to the replay file. We talked about what we need to do here. So, this FS gives us bread and bget, which give us references. It gives us a pointer to a buffer, which gives us the actual contents. So mem, the contents, and then you also have the function bdwrite. Okay, so that's mostly it about what FS is useful for. It gives you a bunch of these. So you can read and write from it. It gives you these buffers, and then you can modify the contents of that buffer. You can read or modify the content of the buffer using mem, or if you are writing to it, you use bdwrite to have it persist. Okay, so that's it for FS. The other one you have to worry about is free map. So free map, let's go to free map. Where free map is. Oh, bitmap. Okay, there we go. So yeah, so free map is a bitmap. And okay, so this is a very cool C++ class. If you want to learn more about what this is called a move constructor and a move assignment. Feel free to ask. It's very cool. If you take CS106L, you'll learn all about move construction. Okay, there's this really interesting class called a bit reference. And this is important because this gives you a reference to a single bit. And then when you call the at function, that gives you a reference to a single bit. Okay, so if you need to modify a single bit, right, let's say you got the bitmap. Let's say you have the bitmap, so free map, right? If you have the bitmap, what you can do is you can call the .at function, .at, and you can give it, some index. Let's say index 10. Okay, you can either check if it's true, so you can say if this is true, so that you're reading a single bit. You can also write to it. Because it's a reference, you can do set this to equal true. That would work as well. That would go into the free map and actually set bit number 10 to true. Okay, the reason this works the exact same way as, if this was a vector, this works precisely because vector, the bracket operator, returns a reference. So if you modify that reference, then you actually modify the contents of the vector. Same idea here. Okay, so if you need to modify the free map, you can just use a syntax that looks like this. Okay, I think that's mostly it for everything I want to talk about. Let me check. V6, the buff, and the log entries. Cool. Okay, I've pretty much gone through everything. Oh yeah, I want to talk about testing. So again, there's a lot more to this project than the actual code you have to write. A lot of this project is understanding what's going on so that if it comes up on the exam, you know what to do. It's also just very cool C++ wise. Again, ask me on Ed if you want to know anything about the C++ in this project. But if you want to do those two things, you use these helpful tools. These helpful tools, what they do is it creates a file image for you. It creates the file system. And then what you can do is you can tinker with it. You can, you can try running, you can try adding or removing files. You can try corrupting different files. And then you can actually print out the contents of the file system. You can look at the inodes, you can look at the logs, you can look at the blocks and the inodes. Yeah, you can do all of that. You can try the file system consistency checks, all very cool, fun to experiment, highly recommend. But I know a lot of you are short on time. So if you are just writing the code and just getting to studying for the final exam, I would not use these tools. And instead, I feel like the code is short enough that you can just brute force do the run tests, write a little code. Each function is like 5 lines-ish, 5 to 7 lines of code max. So you won't be writing too much code. Write a little code and then try running the tests. And then hopefully you'll start passing some tests pretty quickly, just with a little code. So I feel like that should help you get started on the assignment very quickly. Okay. All right. I think that is it for this project. Okay. Otherwise, I just wanted to thank everyone for hanging out with me in all of these videos. Yeah, I really hope some of these videos were all helpful. Give me a like, give me a subscribe. And if you have any comments or feedback about the videos, feel free to email me. My email is averywong@stanford.edu. You can also post on the ed post, the FAQ that I put every week. And then if you have feedback, you can also send them on the course reviews. We'll be looking at those, and your feedback will help make these videos more helpful for future CS 111 students. Okay. All right. Otherwise, not have a good night. You're all going to watch this in the morning. So have a good day tomorrow when you watch this, and good luck on the assignment. And also best of luck on the final exam. Bye.